Hello, and welcome to a special episode of Crossword Radio. The Wednesday New Yorker solve is uploading now, but I'm looking right now at yesterday's New York Times to show this answer here. A logic puzzle invented by a math teacher as a teaching tool, KenKen. And I knew what this is because I do KenKen puzzles. I enjoy them. And I thought that maybe we could do some today. So you can see what that's about for anyone who saw the New York Times yesterday and maybe was curious about this puzzle. So let's take a look. This is just the website KenKenPuzzle.com. Very simple, very straightforward. Look, here's a man himself, Will Shortz, editor of the New York Times Crossword. So you know it's legit. So you can see that Sudokus are typically, this is a sister puzzle of Sudoku, I should say, where it has the same kind of row and column restriction where, you know, you can't repeat a number in a row or a column. But you can see it does not break up this 9x9 grid into 3x3 sections. They're all different kind of shapes. Sections, and you can see if we go to one of these like this one, that there's always a number and then a mathematical operator, and you should be able to basically provide that, apply that mathematical operator to the numbers in that cell. This little section of a KenKen is referred to as a cell, and get that number. So 3 with the division symbol means that you should be able to divide these two numbers in this cell to get 3. And a cell like this that just literally has the letter 2 means you just stick the letter 2, the number 2. Means you just stick the number 2 in there. Minus, divide, obviously you have your standard addition, subtraction, division, and multiplication going on. And you also see that KenKens aren't just 9x9. They can be anything from 3x3 up to 9x9. And theoretically, they could be larger. There's no reason they couldn't go larger than 9x9. So let's get started, and we'll just go around the grid until I feel like stopping, around the circle here. And let's start. The 3x3, of course, is going to be very, very simple. Once you've done a number of them, these answers will just slide right into place. I can typically do a 3x3 in under like 6 or 7 seconds. When our only numbers available to us are 1, 2, and 3, a divide by 2 must always must be exactly 2, 1. Once you get to 4 and higher, this could be either 2, 1 or 2, 4, but because we're still so many few numbers available to us, this must be 2, 1. So this cell right here, of course, just takes a 3. Now this multiplied and 6 means this is 2, 3. Those are only two numbers that we have that will work. But you can see the 2 here means this cannot be the 2. And, of course, also this 3 means that this cannot be the 3. So this is kind of solved for us by this 2 and this 3. And without even having to solve anything, we can see that the only number left available to us in this column is 1. Again, just like Sudoku, you must have one number of each, 1 to x, no repeats, with x being the size of the grid. This is a 3x3, so this is 1 to 3. And now, if we were just looking at the row here, let's ignore this 1 for a second. This would have to be 2, 1, either 2 or 1. But we can see in order to make the math work, this has to be a 2. When you have this 1 and 1 subtraction, this must be 2. 1, 2. Again, we have 3, 1 here is what this answer is going to be, and we can fill those in 1, 3. Okay. Let's go back. They get more interesting once they get larger, but we'll just go through because they don't take very long. So now that we're getting to ever so slightly larger puzzles, I usually like to start with the gimmies. So here's a 3, and here's a 4. those are the gimmies. And the other things that can be gimmies are when a cell only has one combination that can be. Like this +5 can either be 2, 3 or 1, 4. But this -3 can only be 1, 4. We only have 4 numbers, so that must be what those are. And if this is 1, 4, then that means this is 2, 3. 2 and 3 add up to 5, so in order to make all of this add up to 8, that needs to be a 3, and that will solve the rest of that cell for us. This is now a 2, 1 combination. And we don't have enough numbers for this to work anyway, but now we have 2 cells that each have 1 in them in 2 rows. So that means no more 1s in the rest of the row. So we could not have a 1 in this 24 cell, which we couldn't anyway because we don't have 6. It would have to be 1, 4, 6 if we wanted to include a 1. But anyway, we know this is going to be 2, 3, 4. What else can we do to resolve this? This -1 is going to help us here because with the 3 used, the only -1 we have is 1, 2. That leaves that to be 4. 2, 3, 1, 4, 1, 2. That's why setting up these sort of pencil marks or whatever you want to call them beforehand really is helpful. So now this is going to be 4, 1, which we can solve. And by the way, I set up the pencil marks just by doing holding Shift before you type the letter. So for example, here's our gimme 1. This is another gimme. This must be 5, 1. And in fact, this cell can't be the 1, so that must be 5, 1. A ×6 in 3 cells must be 1, 2, 3. There's only one option for that. And the 1 can't go in either of those 2 cells because of this one and that one. So it must be 1 and then 2, 3. Oops. In a 5 grid, this +9 is also forced. It must be 4, 5, which we can fill in there. And now this row needs a 4. With this -1, we know that's either 3 or 5, so we can put that in there. And this ×10 also is forced. It must be a 1, 2, 5. Anything that is a multiplication that ends in either 0 or 5, of course, must contain a 5. And again, this one and this one mean the 1 is forced over here, and this is 2, 5. Yeah, 2, 5. 2, 5. And look, this 5 is solving that for us. So that's 2, that's 5, and now that's 3, that's 2. This still must contain a 2, and now this this column only needs a 4. With 1 and 4 used, our only -3 available to us is 2 and 5. And that solves, and that solves. Now with 1, 2, 5 used, this +7 must be 3, 4 exactly, and this must be 2, 3 exactly. Now 1, 3, and finally 4, 5. There we go. Let's keep moving to the 6x6. Here's where things start to get a little bit more interesting. You know, the 3x grid I can usually do, like I said, in under 10 seconds. Usually about 6 or 7 seconds on average. The 4 grid I can usually do under 30. 5 usually takes me about a minute. But 6 and up, you know, depending, now they can start to get pretty difficult. And it might take me 2 minutes, 2.5 minutes. Maybe it'll take me 10 minutes. We'll see. Although 6x6s are usually not that bad. But like definitely 7s and up, you can get some tough puzzles. So let's go. We have a lot of gimmies here to start. So this a +3 must be a 1, 2 combination, and these 1s down here are preventing this from being a 1, so that must be 2, and therefore that 1. This times 30 must be 5, 6. Now that we have 6 available to us, these divided by 2s could be 2, 1 or 2, 4, but they could also be 6, 3 now. But with this 6 in the 30 is preventing this from being 6, 3. So we know it's must contain a 2, either 2, 1 or 2, 4. We don't know yet, and I'm not going to bother filling that in. But we know that at the very least there's a 2. Same thing with this. This 3 is preventing this 2 from being 6 and 3. So we also know that there's a 2 there. Now here, I could have filled this in a while ago. This 3 square 9 cell, because really only exactly one way to make this work, and that's to double up on our 3s. So you can see, unlike in Sudoku, where you're not allowed to repeat a number within a cell, within a 3 by 3 mini region, in KenKen you're totally allowed to repeat numbers in a given cell as long as you don't repeat them in the row or the column. Those are the only 2 rules you must abide by. Okay. And you must make the mathematical operators work, of course. So, we can actually solve this -2 in a number of different ways here. We can see that we have 1, 2, and 3 used, so that 4 6s are only left. We can also look in this row. See, this is either 5 or 6, and we have 1, 2, and 3 used. We haven't put a 4, so there must be a 4 in here. It's not 4, 2 because of that, so it's 4, 6. There's always different ways to approach this, and because we know this must be 4, 6, we know that this can't be a 6. So there, that's 5, and that's 6. This is another gimme here. This is 3, 5, and that 3 is solving it for us. This column only has 4 left to put in it, so that must go there. And this is either 2 or 6. We don't know yet. Once again, we have a divided by 2 that could be 6 through, that could potentially be 6, 3, but it can't because that 3 is preventing it. So this is either 2, 1 or 2, 4. In fact, that 1 means it's 2, 4, which we can solve. And that solves that. This -1 now is a given. It's just 5, 6, again, which we can solve. This must now be a 1 to complete that row. And now to make this 10 work, we must get to 9, and it's not going to be 5, 4 because of that 4. So our only other option to get to 9 is 6, 3, which is solvable. That gives us 1, 6, and 4, 6 up here. This now must be 2, 4, and this must be 2, 1, which is solvable. 1, 2, 3, and 6 means that this is a 4, 5 combination. Not quite solvable yet. What about here? This must be 2, 5. Now we have 5s here, 5s here. So no more 5s in this row, which we could see from that 5 and that 5 anyway. So not enormously helpful, but how about what else would be helpful? In fact, if we look in this column, we haven't yet placed a 1, and we know it doesn't go here or here. So this is forced to be a 1, 2 pair, like that. That can help us solve these here, and then it's just a matter of polishing it off. Okay, how long have we been recording for? 13 minutes. Oh, that's nothing. Let's keep going. Let's do 7 by 7. Now that we've reached the puzzles that include 7s, 7 is a very useful number because it is so restricted into which cells it can go into, because it doesn't multiply or divide very well. And one thing that can be useful to know, I don't see it in this puzzle, we might come up, but there's a little shortcut where you can look at a 3 or 4 digit number and a little quick gimmick to tell if it's divisible by 7, which can be helpful. Just like, if you add up all the numbers in a 3-digit number or any digit number, you add up all the numbers. If that number is divisible by 9, then the whole thing is divisible by 9, and that works for 3 as well. Anyway, so this is a 7 by 7. Let's start with the gimmies. In a 7 by 7, a plus 13 must be 6, 7. Here we have 4, 5. That looks to be about any of our obvious gimmies. Actually, no, not quite. This one is actually fillable. 45 is 9 times 5. Again, if it ends in a 0 or a 5, it must, and its multiplication, it must contain a 5, and 5 goes into 45 9 times. And the only way to get 9 in multiplication is 2, 3 with the numbers that we have available. If we had 9, then we could do 1, 9, but we don't. So we must do 3, 3, and then 5 is the only way that works. This 60 also must contain a 5, and 60 divided by 5 is 12. So we need to put two numbers in here that multiply together to get 12. Well, that's either going to be 2, 6 or 3, 4, and it can't be 2, 6 because of the 6 here. So we know that this is 3, 4, 5. And what does that leave? 3, 4, 5, 6, 7. That leaves 1 and 2, both of which are possibilities in this in so far in either cell. If that's 2, that could be 3, and if that's 1, that could be 6. So one thing that we, especially again now that we have that 7, one way to make progress is to look in a row or a column or something and think, well, where can I put 7? So I can see in this row here, we are fairly restricted in where we can put the 7. It obviously doesn't go into any of the divide by 2s. We can't put 14 in a single cell. If the 7 went here, these two would have to add up to 4 without repeats. So it couldn't be 2, 2. It would have to be 1, 3, and it can't be 1, 3 because of that 3 there. So that's not 7. None of these are 7. So the 7 must be in this -3 cell, which means it's 7 and 4. And both of our 7s now are used up, so the rest of this row has no 7s, and that actually solves this for us. This was either going to be 6, 1 or 7, 2, and now that we know that it can't be 7, 2, it must be 6, 1. And once again, now no 6s either, so this is not 6, 3, but we could have figured that out earlier. So it's 2 and either 1 or 4. That we don't know yet. But let's keep going. What else can we do? Well, since we have 2 divided by 2s that see each other fully. So they can't share any numbers between them because they're in the same row. So one of them is going to be 2, 1, because then they can't be 2, 4 because of this. And the other one is going to be 6, 3. So effectively, we know that we don't know which one is which yet, but we know that one of them is 2, 1 and one of them is 6, 3. That means this is 5, which actually we also could have gotten just by asking ourselves where 5 could go, because 5 can't go into any of the division cells, because again, we can't put 10 in a single grid. So how about this? 11 minus 5 is 6, so this must add up to 6. It can't be 3, 3. Obviously, we can't repeat. It can't be 5, 1, so it must be 4, 2. And now this is solved here. It looks like it's going to be 1, 6, 7, which does indeed add to 14. Any way we can reduce any of those? It doesn't look like it at the moment. What else? What is next? Aha. With this 6 here, this can no longer be a 6. And if this can't be a 6, then that can't be a 1. So that's 2, 1, 3 to make that math work, and 2 here to make this math work. That gives us 4 and 2. And therefore, this must be 4, 7, which we can solve. There we go. And if we look at this times 60 here, we knew that it contained a 4, and now it can't be here and it can't be here. That's the only place left there a 4 can go. So this is a 3, 5 double. How about this? This could still be 2, 1, or it could be 6, 3. How about this one? This could also still be 2, 1, or 6, 3. So no help yet on either of those. Let's see. 7 could go in any of those squares. Well, there's something. Here we go. Where does 7 go in this row? Again, that's always a useful question to ask once you get to grids that are big enough to include a 7, because the 7 is so restricted, is where does it go? It doesn't go in divide by 2, obviously. Doesn't go in here, because if it did go in here, it must be 7, 4, which it can't be. And obviously it doesn't go in this divide by 2. So that must be 7. And then, in fact, to make the math work, that must be 6. So we have 1, 6, 7. That lets us fill that out. Any restriction yet on these divided by 2s? Can we resolve them? I still don't think so. No. Okay. Let's keep going. Oh, here's something. Again, asking where 7 goes in this row. I was looking, well, it could go here. It could be 7, 1, 2, but it actually can't be here. This 7 is here, and this 7 means the 7 can't go here. And actually, the 7 can't go here, because, again, we have our 2 7s already for these 2 rows, these 2 columns up here. So this also cannot be 7. So the 7 does not go in this plus 10. It obviously doesn't go in the divide by 2. So this is another 7, 3. So 3, 6, 7 are already used up in this row, and we need to get to 3 in 10 letters. And we need to get to 10 in 3 numbers. Geez. With 3, 6, 7 already being used up. It could be, so it must include a 5. It's either 1, 4, 5 or 2, 3, 5. Can't be the 3, so it must be 1, 4, 5. 4, 5, 1, 4, 5, and therefore that is a 2. That's either 1 or 4. That 4 is telling us that this is 1. With 1 and 4 already used, this cannot be 2, 1 or 2, 4. It must therefore be 6, 3. And then this is 5, 2, which is solvable. Okay. Let's see. Any additional progress yet? How about this plus 8? What can this plus 8 be? It can't be 5, 3. It can't be 6, 2. Because this 2 and this 2. And it can't be 5, 3. So therefore it must be 7, 1. Which is solvable. 3, 7, that'll get us a bunch of numbers here. Using letters because I normally do crosswords. We got a break-in up here. That will definitely help us. Now we just need to finish off these last couple. Can we solve this? Yes. This one and this one means this cannot be the 2, 1. Therefore, this is the 1, 2. This is the 6, 3. 5, 3, 4, 5, 1. That is 4, and therefore 2 or 6, 6, and then 5, 2. There we go. How long have we been recording now? 23 minutes. Let's see if we can squeeze in the 8 by 8. I'd like to try to keep this under a half an hour, or around about a half an hour, let's say. So 8 by 8 introduces a couple of wrinkles. We now have an additional option for any divided by 2s. They can now be 2, 1, 2, 4, 6, 3, or 4, 8. We also, divided by 4s go into the join the party, because now there's 2 options for them. They can either be 4, 1 or 8, 2. So, as usual, like I said, let's start with the gimmies. The only actual literal gimme cell we have is this one. But we have a couple of other things that only have one option. That's 3, 5. That's 2, 5. Oops. 15 is 8, 7. It must be that, plus 15. Plus 3 is 1, 2. So therefore that can't be a 2. So that's 5, 2. For any of the other ones that jump out at me, right away. Not seeing that. So now that we're high enough, it could be useful to know, and again, I talked about sevens are always useful to try to think about where they can go. So 192, off the top of my head, I don't know if that number is divisible by 7. However, there are a couple ways you could do that. An easy way, just off the top of my head, is that I know that 140 is divisible by 7, right? Because 14 is divisible by 7. Everyone knows that. And you can slap a 0 on it, still divisible by 7. So 7 times 20 would be 140. So that would be, then we're left with 52. Is 52 divisible by 7? Well, we know that 56 is 8 times 7 is 56. So this is not divisible by 7. But the actual sort of gimmick is a little bit complicated to explain. So you take a multi-digit number like this, 192. You separate the last digit from the rest of it. So you have the n, but you keep the other two digits together as a single number. So separate off the last digit, which is a 2, and 19. So we're left with 19 and 2. Think about like a line between these two numbers. We have a 19 and we have a 2. So you double the number that you separated off, and then subtract it from the remainder of the number that you split from the other side of the number that you cut off. And if that number is divisible by 7, then the whole thing is divisible by 7. I know that seems crazy. How does it work? I have no idea that works. But so we can think that, so 192, that turns into 19 minus 4, which is 15, which is not divisible by 7. By the way, 0 does count, so we can see for 42 if we apply that trick. So separate the 4 and the 2, double it, subtract to get 4, subtract it from this number, you get 4 minus 4, which is 0, and that is divisible by 7. And we do know that 42 is divisible by 7. 7 times 6 is 42. So we know that there's a 7 here. What we don't yet know is it 761 or is it 732? So that will come up. Oh, there is a 3 here. I just somehow missed this cell. 11. What can 11 be? Well, 11 can be 7-4 or 8-3. Well, it can't be 8-3. So it's 7-4. Now with 2, 3, 4, 7 used, 5, 8 is our only minus 3 left. And one, just in this particular website, the way that they lay out these numbers, one little trick you can use for minus 3s, because minus 3s come up a lot, is the available options for minus 3 are the numbers that are directly on top of each other. So 1, 4, 2, 5, 3, 6, 5, 8, and 4, 7 all work for a minus 3. So we knew that 2, 3, 4, 7 were used. So 2, 3, 4, 7. The only two numbers that leaves on top of each other are the 5 and the 8. So that's one way to just, in this particular website, to go through that real quick. So what are we left with here? 2, 3, 4, 5, 7, 8. 2, 3, 4, 5, 7, 8. So 1 and 6. This is almost certainly not going to be 1. In fact, it's impossible for this to be 1, because then these two numbers together would have to be 8 or less and multiply to 192. So this is not 1. That's 1. And this is 6. Can I come up with 192 divided by 6s off the top of my head? I don't think so. 20 times 6 is 120. That leaves 72. What is 24 times 6? It would be 120 and 24, 144. Nope, we still have another 18 to go. So that... Not sure. We're getting close. It's not 24. Can't be 25. Can't be 26. Can't be 27. Can't be 28. What is 28 times 6? That's 20 times 6 is 120, and 8 times 6 is 48. So 120 and 48 is 168. So still not there. 29, maybe 32. What's 32 times 6? 30 times 6 is 180, and 2 times 6 is 12. There we go. So it's 32, which luckily for us only has one option it can be and only 2 squares. That must be 4, 8. All right. 4, 8. This can still be 6, 3 potentially. It's no longer 8, 4. But it could be 2, 1 or 6, 3. This 6. So if this was going to be 7, 6, 1, this would have to be the 6. But so far that looks okay. 1, 2, 5, 7. What are our options for minus 2? With 1, 2, 5, 7 used, it must be 4, 6 or 6, 8. So it contains a 6. We just don't know what the other number is, but that's okay. And I was saying 7 is used because, again, we have a 7 here and a 7 here. So in these 2 rows, all of our 7s are used up. No more 7s. So here's, speaking of all of our 7s being used up, 12 minus 1 is 11. So what are our options here? Our options for this are not 7, 4. They're not 6, 5, because this 5 and 6, this 6 here and this 5 means this can neither be 6 nor 5. So there would be no way for it to be this to be 6, 5, not 7, 4. So therefore it must be 8, 3. Okay, making some progress. Making some progress. Is there any way that we can say that this can't be 7, 2, 3? I don't think we can yet. Right. No, I don't think we can. What else? What else? Here we go. 56 must contain a 7. It's 8 times 7. But we're again, we don't know if this is going to be 7, 4, 2 or 7, 8, 1. So the 7 is all we're sure about here. 96. Let's see. That's 12 times 8. But I don't think that necessarily means there's an 8 in here. I don't think so. Just because it could be 8 and then 2 numbers that multiply to 12, but you could like take the 2 or the 4 out of the 8 and then add it, combine it with a 3 or something, you get a 6, or there's a lot of ways this could go. So I don't think it necessarily means that this must contain an 8. Okay. No 7s, no 8s. That's about it, all we have for this row. What else? Is there anything we can do here? 4, 8 is used. We divided by 2, a minus 2, and a minus 1. If the divide by 2 is 6, 3, 4, 8, and 6, 3, we have 7, 5, and 1, 2 for our minus 2 and our minus 1. What if the divided by 2 is 2, 1? So then we have 1, 2, 4, 8. That wouldn't work, actually. So if this was 2, 1, so we can see that we'd have 1, 2, 5. Yeah, let me just do this up here. 1, 2, 4, and 8 used. Our remaining numbers are 3, 5, 6, 7, and we need to get a minus 2 and a minus 1 out of those. And we can't get those. Oh, we could. 5, 3, and 6, 7. Wait, I'm stupid. So that works. And also, if it was 4, 8, 6, 3, that would be our minus 2, and that would be our minus 1. So, never mind. They both work. So we have to find some other avenue into the puzzle. This is either 1, 7 or 8, 2. Well, there's maybe something. This 7, 8 here means we know this contains either... Sorry, this contains either a 7 or an 8. And wherever that is must be here. And this is either 1 or 2. Does not help us a ton here. That means this can't be 2, 1, because then there would be nothing for this to be. But it could still be 2, 4 or 6, 3. Oh, it can't be 8, 4. In fact, we had something sitting here a while. This 3, 8 means this cannot be an 8. 4, 8. So this cannot be 8, 4, but it still could be 2, 4 or 6, 3, I think. Oh, nope. Once again, can't be 6, 3. I'm wrong. This 3 comes down here and tells us that that has to be 5, 3. So this can no longer be 6, 3. Can no longer be 8, 4. Must therefore be 2, 4. And then 1, 7. Okay. Very small, minor amount of progress. Let's see, what are we left with in this row? 1, 2, 3, 4, 5, 8. So 6 and 7 are left. This cannot be a 6 because this square here, because then this would have to be 3, which it can't be. So that's not 6. So that is 6. And that is 7. 2 minus 1, that's have to either be 5 or 7. Can't be 7 because of these two 7s up here. So it's 5. This is 7, 1, it looks like. So therefore this is 6 to make the math work. Here we go. Here we go. Are we possibly cooking with gas yet? No 8s, no 7s, no 6s. So 6, 7, 8 are what is necessarily used. It's very easy to get 2 minus 1s out of that, you know. What are our options? 1 or 3, 6, 7, 8. Right, if either of the 1, then the 2 minus 1s would be 2, 3, or 4, 5. And if it was a 3, then it would be 1, 2, or 4, 5. So never mind. Nothing we can get out of there. Does this give us here anything here yet? This could be 2, 1 or 6, 3. Any reason, anything stopping it from being that? This we can fill in. This cannot be 8, 2 now, so it must be 4, 1. There's something. 1, 2, 4, 7. We do have 2 minus 2s left. 1, 2, 4, 7. We could either do 8, 6 or 5, 3. However, we can't put 5, 3 in here because then 8, 6 would have to go in here, and that adds up to more than 11. So this must be 8, 6, which we can do. And therefore, this must be 5, 3, which add up to 8. Which we need to get 3 to get to 11. So there we go. Slow progress. What do we have here? 1, 2, 3, 4, 5, 7. So 6 and 8 need to be used. There's no way for... Wait. This can be either, I think. If this is 6, this is 1. And if this is 8, this is 3. Both of those seem okay. And 96, again, is 12 and 8. Obviously, 12 has a 6, and 96 has an 8. So there's lots of ways for this to work. But let's see. What is 96 divided by 6? Let's see if we can some way we can disprove that. 96 divided by 6 would be... slightly more than 12. Would it be 14? It'd be 60. 14 times 6 is 60, and 24 is 84. So no, a little bit that. So would it be 16? 16 times 6 is 60 and 36. Yeah. Well, there's actually no two ways. It could be 682 if this was 6. If it was 8, it's 12. So it could be 834 or 682. And if it is 834, then this is the 4 and this is the 3. Oh, it can't be. Aha. Cannot be 834. But could be 862. If the 6, I already forget what we said. 6 would have to be 82 because it's not 834. I think just this whole thing must be 268. No matter how you slice it. Okay. Which means that can't be 2. 8, 7. Can we answer this yet? 6, 4, 6, 8. We can. Which means that's 3. 8. Right. 1, 6, 8, 7. 1, 6, 7, 8. 2, 3, 4, 5. This cannot be the 2, 3. So this must be the 2, 3. Therefore, this must be the 4, 5. That gives us 7, 4. This column only has one digit left. What is it? 1, 2, 3, 4, 5, 6, 7. It's 7. So this is either 6 or 8. Can't be an 8. Must be a 6. So this can no longer be 6, 3. This must be 2, 1. And then this is going to be 5, 3. Excellent. Have I missed anything? So no 1s we've used up. 2s in these columns we've used up. And 4s we've used up. So 1, 2, 4. So yeah, this cannot be 6, 1 because we've already used up our 1s. So it must be 8, 3. 8, 3. That gives us a 6 here. 2, 3. 1, 2, 4, 1, 6, 4. Okay, what is this? This is going to be 7, 6. There's our 7. So this is 8, 1. Make the math work. We've used up all of our 8s for this row, so this cannot be 8, 2, so it must be 4, 1, which resolves these over here. And finally, we're left with 2, 4, it looks like. Alrighty. That was a slow 8 by 8, but I was talking through it the whole time as well. Anyway, there we go. That's KenKen. I don't feel like doing the 9 by 9. Already been recording for 43 minutes for this video. So, yeah, there's some KenKens. If you found any of that interesting, check them out. The website is kenkenpuzzle.com. They say you have to buy it to ban the ads, but guess what? You can install an ad blocker and block the ads by yourself, which I've done. So install an ad blocker, people. There we go. This has been the brain. I will see you guys tomorrow. Bye.